Let's not talk about binary compounds because these are the compounds for which you can easily read and write formulas. Okay, a binary compound, binary means two, so binary compound is a compound that is made up of two elements. So which of these compounds, A, B, or C, is a binary compound? C? Good. Okay, why not B? Okay, so don't be tricked by that 2 there. That's a diatomic molecule, but this is an element, okay? Since this is a molecular element, O2 is a molecular element which is made up of diatomic molecules. Diatomic molecules. Okay. A, of course, is made up of 3 elements, so this would be a ternary compound. Okay. So, how do you read and write binary formulas? Well, if it's ionic, you do it just like any ionic compound. If you're given the formula and you're asked for the name, just identify the cation, say the name of the cation, and then say the name of the anion. If you're given the name and you're asked to write the formula, what do? You write the formula of the cation, omitting the charge. You write the formula of the anion, omitting the charge, and then you add subscripts to indicate how many of each you have in a formula unit. So it's kind of simple. Okay, so we've talked about that already. So let's focus a little bit more on molecular binary compounds and see how we can read and write formulas for those. Okay? Oh, not yet. There's a couple of things you need to be alert to when you're dealing with binary ionic compounds. Okay? You need to be aware of the possibility that the anion is in fact polyatomic. So for example, O2 with a -2 charge, that's a polyatomic or a diatomic ion with a -2 charge. That's called peroxide. So you need to know these things. O2 with a -1 is superoxide. Okay? 3 nitrogen atoms forming a polyatomic ion with a charge of -1 is called azide. Okay? Note that this is not the same as N with a -3 minus nitride, which is monatomic. Okay? N3, -1 is azide, N with a -3 charge is nitride. This is monatomic, and this is polyatomic. Okay, so when you see that O2 and N3, be alert for the possibility that it's not oxide. Remember, oxide is O with a -2, that's monatomic. Okay, be alert of the possibility that it might not be oxide, it might be superoxide if you see a 2 as a subscript for O, or it could be a superoxide. Same thing with sulfide and persulfide. S2 with a -2 charge is called persulfide, and if you remember, S with a -2 is sulfide. So if you have a formula that has an S2 in it, be alert to the possibility that it might be persulfide instead of sulfide. Okay, so let's look at this example right here. This Na2O2, if I were to give you this formula, okay, you should be able to figure out that that's not sodium oxide, okay? It is sodium peroxide. Why is that? Well, you can see that this is ionic, right? So I got 2 of the sodiums. You know sodiums, group 1A, would have a charge of +1, right? 2 +1s in the formula unit. Okay, the question is, that O2 part of the formula, is that 2 oxides? Or is that 1 peroxide? Or is that 1 superoxide? Okay, let's look at your positive charges here. That's +2, right? If it's 2 oxides, what would the total negative charge be? -2 plus -2 is -4. It can't be 2 oxides, so it's not sodium oxide. The anion here is not oxide. Can it be 1 superoxide? This is a -2, a +2, and a -2 adds up to 0. So this is sodium peroxide. It can't be superoxide because +2 plus -1 will not add up to 0. Okay? So be alert to that possibility. So let's now look at binary molecular compounds. Okay? If a compound is binary and it happens to be a molecular compound, The only thing you need is actually one of the easiest formulas to read. Okay, you state a prefix that corresponds to the subscript of the first element. If the prefix happens to be, if the subscript happens to be 1, you don't use a prefix. You don't use mono. Okay. Then you state the name of the first element. Okay, and then for your second word, you state the prefix corresponding to the subscript of the second element. And again, no prefix if that subscript happens to be 1. And then you state the name of the second element, but you change the ending to I-D-E. So what are these prefixes? These are Greek prefixes, so you should be familiar with this by now. You use the prefix di if the subscript is 2, tri if the subscript is 3, tetra is if the subscript is 4. A good way to remember that tetra is 4 is if you've seen the game or played the game called Tetris. All of those falling blocks are actually sets of 4 blocks. Okay, so remember the blocks in Tetris look like this. And there's one that has 4 and one that looks like this. Okay, so penta as in pentagon is 5, right? Hexa is 6, hepta is for subscript 7, octa would be the prefix for subscript 8, nona for subscript 9, deca for subscript 10. If you want to continue, undeca is 11, dudeca is 12. Okay, and so let's look at P4010, this example right here. What would be the name of this compound? So first of all, what would be the prefix for phosphorus? Of course, we know this is binary, right? 2 elements. And we know this is molecular. So we're going to use the rules here. So 4, the prefix for 4 is? Okay, so, and then the name of the first element is phosphorus. And then the second prefix would be deca, and then oxide. Usually when you have deca, a prefix ending in A followed by oxide, you drop the A, so you just say this is decoxide. Okay? Instead of tetraoxide, you say tetroxide. Instead of pentaoxide, you say pentoxide. So this compound right here is tetraphosphorus decoxide. Okay. So how can you recognize the name of a binary compound if I gave you one? I didn't give you the formula, but I give you the name. Well, you know binary, you should see the name of the elements in the 2 words, right? The first word should have the name of one element, which may or may have a prefix. Okay? And then the second word, you're not going to see the full name. Okay? You're just going to see the stem of the name, and then that ending should be I. If you remember back here, we said it's decoxide. Instead of oxygen, we wrote oxide. Okay? So, and like I said, there may be prefixes, so that would tell you what the subscripts are for one or both elements. Okay? So, if you recognize that a compound is binary and molecular, okay, and you're asked to write the formula, all you have to do is write the symbol for each element mentioned in the name, right? The first element mentioned, and then the symbol for the second element mentioned, and then add subscripts to correspond to that correspond to the prefix. So we got here, for example, carbon tetrachloride. How do I know this is binary molecular? I got 2 elements, carbon and chlorine, and I can see that the chlorine ending has been changed to "ide." So this is carbon, this is chlorine. What's the prefix for carbon?
C.
There's none because so the subscript is implied to be 1. I don't write a subscript of 1. What's the prefix for chlorine? Tetra. Okay, so the formula then is CCl4. Carbon tetrachloride is CCl4. Now there are some, maybe I should